Hey folks, thanks for coming out today. Appreciate it. Hope everybody's had a great time at re:Invent. My name is Jeff Bartley. I'm a product manager on the AWS DataSync team, and I'm joined today by Raghavendra, who's with the Workday team. He's going to talk to us today. Excited to hear his story about how Workday used DataSync as part of their migration of their Hadoop cluster into AWS. So he'll be talking about that a little bit later. But just from an agenda perspective today, what we'll do is I'll start with the DataSync overview, an overview of the DataSync service, and then I'll go into a deep dive and talk about kind of some of the inner capabilities with DataSync and help you understand a little bit more about the service. I'll then talk a little bit about performance optimization, some things that you can do with DataSync to save a little money as you're using the service. And then also, that's cost optimization and performance optimization, help you get the best performance out of your DataSync tasks. I'll then turn it over to Raghavendra, who will talk a little bit about Workday's story, and then I'll wrap it up at the end there. So if you've ever had to move a lot of data as part of a migration, I used to do this many years ago, you've probably experienced a lot of the challenges that we have listed up there. And when we talk about large-scale data transfers, we're talking about terabytes, hundreds of terabytes, maybe even petabytes of data, millions or billions of files. And I'll work with a lot of customers who will frequently start out thinking, okay, I think I can do this. Moving data ought to be pretty simple. I'll write some scripts and I'll do this on my own. And they quickly begin to realize the level of effort that's required in something like that. You reach challenges around like security. Am I going to encrypt? How do I encrypt my data in flight, keep it safe? How do I verify my data? This is often a big thing, right? Sometimes I'll work with customers and like, look, I'm going to move my data and then I'll just spot check it. Yeah, this file made it and that file made it, but that's okay if it's like 1,000 files or tens of thousands, but if you've got millions or billions of files, trying to spot, it's not going to work, right? So verifying, making sure that that data made it all the way through to the end, super important. Also recovering from errors. I can't count how many migrations I've done where like a quarter of the way into it, I realized, oh man, I forgot to like flip that switch and the metadata is not copying correctly and I got to go back and start all over again, right? Dealing with those kind of errors, making sure you can recover from them cleanly. If you're copying online, thinking about network availability, how do I make sure I'm using my network bandwidth efficiently and effectively, that I'm not taking it away from my other users and things like that. So a lot of different challenges that are out there, particularly when you're moving data at scale. And AWS DataSync was built to help our customers deal with a lot of these challenges that can come up. So DataSync in particular was built with a custom protocol that's built on top of TCP/IP. We use parallel TCP/IP streams to achieve a high level of throughput. Several of our customers can achieve up to 10 gigabits per second per task, and they can scale that out. I've had one customer who is achieving a petabyte a day of data movement using DataSync, so a significant amount of data movement. So we can move data very fast. Security really is job one here at AWS. We say that, but it really is true. And DataSync has built-in encryption in flight and at rest. All data is encrypted in flight using TLS 1.3. And we also have options for verifying data both in flight and at rest as well to make sure that your data is fully transferred byte for byte. And DataSync is a fully managed service, so what we mean by that is it integrates with a lot of the AWS services that you might expect, CloudWatch, logs and events and things like that, as well as CloudTrail. And we also make it easy to connect to the storage services that we support, specifically Amazon S3, Amazon FSx file systems. We support all the file system types that are out there, as well as EFS. And then we've designed it to be easy to use to overcome a lot of those challenges that I talked about earlier. It's got capabilities like built-in scheduling, filtering, you can throttle bandwidth usage of your tasks, and a lot of other capabilities that are designed to make it easier to transfer particularly large amounts of data. Now, our customers are using DataSync really for four main use cases. And the first of these is helping them accelerate their recurring business workflows. And what I mean by that is, a good example I often give is I work with customers in the life sciences space. And these customers may be running things like genome sequencers on premises. And those sequencers are putting out a lot of data on a daily basis. And that data is often going to like a local file system on premises. But these customers are often startups. And they don't have the compute capacity on premises to actually process that data that's being produced. They want to do that in the cloud. So they'll use DataSync as that data is coming off of those machines and copy it in somewhat real time up into the cloud. And then once the sequencing job is done, they'll trigger their downstream processing. So again, helping customers accelerate their data movement as part of these workflows. Migration is another key use case. Customers migrating file systems. Raghavendra will talk about his migration with Hadoop. And then protecting data. So I've got a lot of customers who maybe they have file systems or object storage systems on premises, and they want to make a second copy of that data in the cloud. DataSync has built-in scheduling. You can replicate on an hourly basis, daily, weekly, whatever works for you, or custom schedules. And then archiving. So you guys probably know there's a lot of data out there, and a lot of that data is cold. Think about those PowerPoint presentations you never touched in a year, those Excel spreadsheets that you created 2 years ago. A lot of it's just sitting out there cold. But for a lot of our customers, they have to retain that data for compliance purposes or for other reasons. But it's consuming on-premises space or their on-premises capacity. And so they need to move that data, and what they'll often do is move it into something like S3 or S3 Glacier or Glacier Deep Archive, take advantage of the cost savings that those services provide, and then free up their data on premises. And so moving that data, again, DataSync can help our customers with that. So we'll talk about kind of 3 different ways that you can use DataSync. So the first is, and I've kind of alluded to it, moving data from on-premises locations or edge locations. And we can support really any storage that talks the NFS or SMB protocol, like file servers, Windows servers, things like that, as well as object storage systems that support the S3 API. And then obviously Hadoop, which Raghavendra will talk about. DataSync can also work at edge locations. So the AWS Snowcone device, if you're familiar with that, it's a small form factor, ruggedized device, and it comes built in with the DataSync software on it. So our customers will often take the Snowcone device, go to their remote location, maybe collect some data on it, bring that device back to their office or their data center, plug it in, and use DataSync to copy the data from the device up into the cloud. And then we also, DataSync also supports copying data to and from S3 storage on Outposts as well, so that edge presence. We also have a variety of customers who, for one reason or another, operate in multi-cloud environments. This could be maybe they've acquired a customer or they've acquired another organization that operates in a different cloud, or maybe they've got some users within their organization that have stored data in some different cloud and they want to bring it into AWS. But regardless, it can be complicated to operate in a multi-cloud scenario. And AWS has actually been building out capabilities over the last few years to help our customers operate in these kind of environments, and DataSync is one of those services. And so last year, we launched support for being able to copy data both to and from Google Cloud Storage and Azure Files. And then earlier this year, we launched Azure Blob Storage. And then we added support for a bunch of other clouds there, which all have S3 compatible object storage on them. So you can use DataSync to copy data both from those other clouds into any of those AWS storage services there. So not just S3, but FSx or EFS. You can also copy data from AWS to those clouds if you need it. So in both directions. So giving our customers that operate in these multi-cloud environments some extra help in moving their data between clouds. And then finally, we have a lot of customers using DataSync simply to copy data back and forth between AWS storage services. So this may be copying a subset of your data from one S3 bucket to another. It could be going from EFS to S3. Any combination of the services that you see up there, DataSync can copy data between them, and it intelligently deals with things like metadata translation or making sure that the data lands in the right way in the right format. Because going from a file system to an object storage, these are some of the things that you have to think about. So at a high level, how does DataSync work? Well, you start, if you're copying from an on-premises location or an edge location or even other clouds, you start by deploying an agent, which is a virtual machine. And that agent is set up to connect to your storage. And then you define source and destination locations. And that's simply a way of telling DataSync, hey, here's how you connect to my storage. It's an IP address or a URL, the authentication, username, password, things like that. And then you run a task, a DataSync task, and that task is responsible for copying data from the source to the destination. And if you're copying from on-premises environments, we support copying data through the internet, through AWS Direct Connect, or through site-to-site VPN. Regardless of which method you use, all data is encrypted in flight using TLS 1.3. Okay, so let's go into a deep dive on DataSync. So on-premises transfers, we talked about how DataSync can connect to these different types of storage systems, whether it's the NFS or SMB protocol. We support different flavors of those protocols. So we have pretty good connectivity capabilities there, often having customers copying from like NetApp systems or, like I said, Windows servers or things like that. We support really any on-premises object storage system that's generally S3 API compatible. It doesn't have to be completely compatible with the S3 API. In our documentation, we have a list of the API needs that we support. And then we talk to Hadoop clusters using the HDFS protocol. And then that agent, this is one important thing to note here, that agent doesn't talk directly to the storage services itself. It actually goes through the DataSync service. And the reason that we do that is because it's really that remember I talked about that custom protocol that we have that's built for WAN optimization, high throughput. And so that agent is using that protocol to talk to our DataSync service, which then routes the data intelligently and correctly at the fastest speed to those different services that are located in your environment. And an agent is really intended for communicating with systems outside of AWS. Like I said, that could be on-premises, in other clouds, or at the edge. On a Snowcone device, it's actually the DataSync agent is installed on there. And it's provided as a virtual machine image or an AMI that you can run on an EC2 instance. You can deploy it on VMware, Hyper-V, KVM, or EC2. The nice thing about DataSync agents, the software updates are completely handled by DataSync. You don't have to go in and schedule those or anything. We do it in the background when tasks aren't running and things like that. So we keep all the software up to date. And the basic way that you deploy an agent, you install a virtual machine, and then you activate that agent in a region and account where you're actually going to be using it associated with your storage. So if you're copying to an S3 bucket, you would activate your agent in the region where that S3 bucket is located and your account that you would be using. Now we provide a couple of different ways for that agent to connect into AWS because DataSync is copying data over the network. So the first of these are just public endpoints, and these are our standard available over the internet. Again, the agent is always communicating using TLS, so it's all encrypted in flight. We also support VPC endpoints, and so customers who need private connectivity between their on-premises environments and AWS can use this. You create a DataSync VPC endpoint in your VPC in AWS, and then you can use something like Direct Connect to create that private connection between your agent and your VPC up in AWS. And then for customers who need like FIPS capabilities, this is typically customers working in like US government, in GovCloud, things like that. But we have FIPS endpoints capability as well if you need that added level of security. Now, one thing to think about as you're using agents with other clouds, you really have two options. Because if you remember, I mentioned that you can deploy the agent as an EC2 instance. You can actually also deploy it on the other clouds as well with a little bit of extra work to convert that EC2 Omni to a virtual machine that can run on other clouds. So why you would choose one over the other, well, sometimes you may have data that's compressible. So one nice thing about the protocol that we have is data is compressed in flight. And so for some of our customers who are maybe doing a migration from another cloud into AWS, they're concerned about egress charges. So they can put the DataSync agent in the other cloud And then as it's running, it will compress the data in flight, potentially reduce egress charges out of that cloud. So that's one of the advantages. We've got a couple of blogs out there that talk about deploying the agent in Google Cloud or in Azure. And so you can check that out. Those are kind of the two of the most popular ones there. But you have options for how you can deploy this. We've also had customers who deploy it as an EC2 agent just because it's a little bit easier to do it that way. They can automate it a little easier. And I mentioned that customer who was copying a petabyte of data. That was actually from another cloud, and they were scaling up those EC2 agents, which is a kind of a performance optimization that I'll talk about later. But you have these two options when you're using agents with other clouds. Now, when it comes to AWS transfers, one of the nice things is that there's no agents to deploy because we're talking completely with AWS storage services. So there's no agents to deploy, no infrastructure to manage. You can literally just call an API, say, copy from this S3 bucket to this S3 bucket. It's super easy. And you can copy data within the same region or across regions using DataSync. The nice thing is that all the traffic stays within the AWS network. It never leaves, goes out to the internet and comes back or anything like that. It's all within AWS. And again, all traffic is encrypted in flight. Okay, so DataSync is a task-driven service. That means that it's designed to copy data from the source to the destination. And so a DataSync task it's configured of different things, and I kind of mentioned this earlier, but it's configured through a source location, a destination location, and then configuration options that control how the task actually runs. You might control how the verification works. You might control how data is actually copied, what metadata is copied, or what metadata you may not want to copy, things like that. A few things to remember when you're working with DataSync. So a DataSync agent can run one task at a time. It can queue up tasks if an agent is in use, but it can only run one task at a time. A task copies data from one source to one destination. You can create multiple tasks if you want to copy from different locations, but it's one source to one destination. Today, a task can process up to 50 million files. We're working on overcoming that limit with changes we're making, but that's a limit today. And then you can also, as I mentioned, configure a task to run on a schedule. We support different timeframes. You can also create custom schedules as well. And a task, when it runs, goes through various stages. So it starts at a launching phase, which is where we're launching some of the infrastructure on our back end to process that task. And then you go into a preparing stage where DataSync is scanning the source and the destination and comparing them and figuring out what needs to be transferred. And then we go into a transferring stage where the data is actually being moved over the wire to the destination. And then we go into our verifying stage where we actually verify the data, make sure it's fully landed at the destination, byte for byte. And if anywhere along the way there are errors, we report those in CloudWatch. And we also recently added capabilities to provide more in-depth error reporting, where you can see differences in hashes or checksums, things like that, to get a deeper dive in understanding what went wrong. So again, a little bit of an understanding of how DataSync works. So from a performance optimization perspective, there are a few things that you want to think about, and really a lot of this stems from the fact that DataSync is an online data transfer service, and it's talking to storage systems on both ends. Those are the main things you need to think about here, and there are really three legs to the network path that data transfers that data transfers through as you're running a DataSync task. So you've got the leg from let's say if you're copying from on-prem, your on-prem storage to the DataSync agent. Then you've got the leg from the agent itself into the DataSync managed service. And then you've got the leg from the managed service to the storage. We'll talk a little bit here about each of those. So some things to think about from the agent to storage leg. The first is that DataSync uses these common protocols to communicate with your storage. And so you need to make sure that firewalls and things like that are open between your agent and your storage. We use a multi-threaded architecture on our agent to scale our storage transfers to achieve high levels of throughput and IOPS. So what that means is that we could potentially impact your storage system. And so that's why I always recommend that customers, particularly when they're running against maybe older storage systems, they're migrating from this, this old NetApp or something like that that's running these like 7200 RPM, SATA drives. Like, we're probably going to impact the IOPS on your system, so you want to go check that out because you just want to be careful there. So definitely run a POC there. So as I mentioned, slow storage networking or I/O could impact DataSync performance. You also want to minimize the latency between the agent and the storage. So sometimes customers will come to me and they'll say, well, look, I've got a direct connect from my VPC in AWS down to my storage that's running in my data center. Can I just run the agent as an EC2 instance? And like all good engineers, my answer is it depends. And really what it depends upon is the latency on that network, particularly because storage protocols like NFS or SMB in particular is sensitive to latency. And if there's too much latency between AWS and your on-premises storage, you're going to run into a lot of problems to the point where it may not even work at all. So this is why we typically recommend that customers deploy the agent as close to their storage as possible to minimize that latency. And then we also provide options for encrypting storage communication as well. We do this automatically with the SMB protocol, and we have options with Hadoop and the other protocols that we support. Now for the leg between the agent and the DataSync managed service, again, this is using that custom protocol that we provide. And as I mentioned earlier, the agents communicate with our service, not with the storage. We don't talk directly. The agent doesn't talk directly to S3 or to EFS or FSX. It goes through our service first. You can use Direct Connect or VPN with VPC endpoints for private networking. We provide throttles, so you can configure DataSync on a per task basis to tell it basically how much bandwidth you want it to use. So you could configure it, use 50 megabytes per second or 500 megabytes per second or whatever, and you can actually change that throttling dynamically as the task is running. So I've had some customers who run really long tasks for a long period of time, and during the day they throttle it down while their business processes are utilizing the network, and then at night when all their users go home and they stop using the network, they throttle it back up so that DataSync can use more bandwidth. We compress data where possible for sending over the wire, and again, it's all encrypted in flight using TLS. And then on that last leg there between the DataSync service and the AWS storage, again, we're using the common storage protocols, NFS, SMB, S3 in this case. DataSync manages this connectivity automatically. There's nothing that you need to do. You do need to configure it a little bit. So like when we're talking to S3, you need to give us a role that our service can use to talk to your bucket. But that's pretty common for talking to AWS services. But again, it's the same caveat applies here. You can configure some storage systems in AWS, like FSX for Windows. You could configure it with HDD storage, and the IOPS are going to be a lot lower than if you configured it with SSD. So the same caveats apply here. DataSync is a multi-threaded service. We do some optimizations when we're talking to certain services to make sure we don't try to overwhelm them, but you still want to keep in mind if you've configured your file systems or your storage to be a little, with lower cost storage or something like that, you could run into I/O issues as well. So just keep that in mind. We encrypt traffic automatically. We provide options to do that. And again, all traffic stays within the AWS network for that particular region where your storage exists. So I talked earlier about this customer who was copying a petabyte a day, which is a lot of data, by the way. That's like you're operating at like over 10 gigabytes per second. It was a huge amount of data that they were copying. And the way that they did this was effectively by deploying multiple agents. They actually had 30 different agents, and every one of those agents was running an individual task. And then they configured their tasks to point to certain prefixes in their object storage. And then they just kicked off DataSync and started running it. And so all of those tasks were running simultaneously, pulling data from different locations in their storage, but all doing it in parallel. So they really able to reach high levels of throughput using this method. So this is one way to increase your throughput. And you don't have to run it in the cloud. You can do it on premises as well. Typically with customers who have like a 10 gigabit per second link, the way that they'll max that out is usually with like 3 or 4 different tasks running in parallel if they're looking to do a high-speed migration. So this is one way to get a higher level of throughput using DataSync. Another option that we have is you can actually use multiple agents with a single task. Now, the reason that you would do this is if you have a data set with lots of small files where you need higher IOPS rather than necessarily throughput. And so you can assign up to 4 agents to a single task. And then what will happen is each one of those agents will be copying a lot of files in parallel. So this is one approach that you can use if you're migrating, for instance, a system with a lot of small files on it. So that was a lot for performance optimization. And then from a cost optimization perspective, there are some things that we do as well. So DataSync charges on the amount of data that we transfer. So we charge on a per gigabyte basis. And DataSync is always doing incremental transfers. That means we only try to copy the data that is actually changed on the source, between the source and the destination. And the way we do this is during the preparing phase, we scan the source, we scan the destination, we compare them both at the data and metadata level and see what's changed and then only copy what is actually changed. And so that in that way, we're not trying to copy the same data over and over and over again and charging you for extra stuff. We're only doing those incremental transfers. You can also use filters to narrow down the data that you need to copy. So for example, you might have a file structure that looks something like this, and you might say, I only want to copy folders C and D. Well, DataSync has filtering capabilities. We have an include filter capability where you could give it this string that says, hey, only copy folders C and D. And in that case, DataSync will completely ignore folder A and folder B. We won't even scan it at all. We just completely ignore it in the preparing and transferring phases. We also support exclude filters. So you could say, hey, don't bother copying files of a certain extension or something like that. So again, this is a way that we can also limit the amount of data that DataSync is scanning and transferring. And then the last one is really the ability to do direct transfers into S3 storage classes. So if you're familiar with S3, you know that there's a cost to running lifecycle policies to transition data from one storage class into another. Using DataSync, if I want my data to land in Glacier, or I want my data to land in intelligent tiering or whatever, you can configure DataSync to copy directly into that storage class, removing that need for lifecycle policies to transition objects and things like that, and save yourself a little bit of money. The one caveat when using DataSync with S3 is just to be aware that S3 has request charges. So if you're using DataSync to copy a lot of data to and from S3 over and over and over again, DataSync is doing things like listing and doing heads on the objects, and that can lead to some request charges in some cases. So just something to be aware. You have to have like millions and millions of objects that you're scanning and doing this with, and you have to be doing it on a frequent basis to see any kind of real impact, but just something to be aware of, because sometimes that does affect our customers. Okay, and with that, I'm going to turn it over to Raghavendra, who's going to talk about Workday story using DataSync.
Thank you, Jeff. My name is Raghavendra. Hi, everybody. I lead the operational data lake team at Workday. I'll be talking about the Workday journey of data migration using DataSync. Quick introduction about Workday, what Workday does. Workday is a cloud-based human capital management, HCM, and financial management company. Workday provides solutions for many managing aspects of organizations such as HR, payroll, benefits, time tracking, talent management, and more. Workday's HCM platform provides solutions for organizations to streamline their HR process, improve workforce management, and enhance employee engagement. In addition to HCM platform, Workday also offers financial management solutions to help organizations manage their financial operations such as accounting, budgeting, procurement, and financial reporting. Okay. Before migration, we were operating operational data lake for about 8 to 9 years with 10 petabytes of historical data and continuous streaming data in on-premises, right? During this period, we encountered several limitations running such large operational data lake in on-premises. Some of them are aging hardware and network constraint, right? Due to limited capacity in the data center, hardware maintenance, frequent hardware maintenance, and limited capacity in the networking. Then as the business and the company grew across different geographical locations, we also had challenges with geographical constraints, such as limited redundancy in the geography, disaster recovery, higher latency for remote access, and challenges on geolocal data regulations, right? And then lack of elasticity, primarily driven by limited capacity and automation on the infrastructure in on-prem, and inefficient resource utilization due to homogeneous hardware and inefficient capacity planning and limited fault tolerance. And finally, some of the cost challenges with on-premises data center for such a large data lake. You would have to do upfront hardware investments, ongoing maintenance and upgrades, as well as licensing and software costs, and some of the challenges with units of economics of scale, right? So all this put together, we strategically made a decision to move operational data lake to the cloud, which unlocked greater scalability, cost efficiency, accessibility, and also enabled our platform for modernization. So when we started evaluating data migration solution for our use case, we had three choices, three solutions. DataSync is one of them, Snowball Edge, and S3 distributed copy. With Snowball Edge, quick definition of Snowball Edge. Snowball Edge is a physical device which has both storage and compute capabilities. You copy the data offline, connect it to the data center, and then ship it to the AWS data center. From then, you ingest into AWS storage services. And S3 distributed copy is a command line tool that supports parallel processing between Hadoop, HDFS file system, and S3, right? We made a choice to move forward with DataSync primarily because of the flexibility and the agility it provides during the migration process. For example, we have the ability to control the networking speed or the data transfer speed during the migration. Second, we also have the ability, which is a powerful one, to incrementally copy the data instead of reprocessing the data from the beginning in case if you encounter any errors, which happened in our case. How did DataSync enable petabytes of data migration for us? If you look on the picture, on the left, you have the on-premises. On the middle, you have the migration account, which was a temporary account we established for the migration process. And on the right, you have the production account. So on the left, you have the production Hadoop cluster, which is completely isolated. And then we deployed the staging, in the staging cluster, all the DataSync agents, querying the data or querying the files in the HDFS that is running in prod, so that we do not disrupt any of the existing applications that are using the prod HDFS cluster. The data agents are connected to Direct Connect Gateway through the DataSync VPC endpoints that is on the migration account. And through that, we copied all the data as is to the raw data bucket. This is an intermediate data bucket where we had all the files that were copied from the HDFS to the raw data bucket. The primary reason we have taken this approach, where there is two-phase approach, copy raw data first and then transform the data, is primarily because of limited capacity that we had, limited compute capacity that we had in the data center. Once we copied the data to the raw data bucket, which is an intermediate data bucket, we then applied our transformations and business logics to that data that was copied in the migration account through EMR, Spark Jobs, and then finally writing it back to production account, which is the final data bucket. That is where the users query the data. During this process, we also encountered several challenges, not specific to anything specific to DataSync. This is more of the challenges that we encountered during the migration process. First thing, if someone is starting with the DataSync, and if you already have a custom validation of your data, I would highly suggest to disable the checksum that is within the DataSync. It will enable faster data transfers and also the migration. We also face some challenges with S3 output writer for a custom partitions. Defining the right prefix for S3 is very key in terms of the performance of S3 writes. So that's another one. Third one is transforming data from one file format to another file format during the migration is very key. And most of the cases, that's what happens during migration. Our historical data was sequence files. We have to transform it to Parquet file. And most of our files that was residing in the on-prem did not had any sort of schema-related, schema-associated and schema evolution, right? So we have to transform all those sequence files from sequence files to the Parquet files. That was one of the challenges. The other one is managing and optimizing data transfer speeds such that you do not impact the existing network flows where there is other applications running and then it causing exhaustion on the networking capacity. Addressing any unexpected errors or failures and reprocessing the data with checkpointing. This is also key. You do not want to go for a long process and then copy all the data and finally realize that the data was not valid and then reprocess the data. It's always important to have some level of checkpointing during the data migration. And handling potential data integrity, tracing back to source systems. This is one of the key things. DataSync has the ability to identify files that has been already migrated or moved to the S3, and then if you go back and change that file for any reason, it would copy the incremental data automatically. The reason for this is an important feature is because in our case, we identified several files was corrupted during the transfer or from the source system itself. For example, in the HDFS, we had some corrupted replicated data which was copied by DataSync, and then we have to go back and correct those replicated files. Automatically, DataSync will copy those files back to S3 in an incremental fashion. Finally, what is the impact on this journey and what was our takeaways? First, we had predictable data speed that helped in planning network capacity. Networking was a huge win for us using DataSync. Second, two-phase approach enabled thorough testing of major transformations, which were then reused for our streaming pipeline. So during this migration process, all our transformations were well tested. We reused similar business logic and the code for streaming pipeline for in-flight data. Improved SLAs and data reliability when compared to on-premises because of aging hardware and frequent hardware failures and so on and so forth. This platform on the cloud, the new platform, enabled modernization, accessing to cutting-edge analytics tools that support different use cases such as machine learning and AI. So wrapping up, I'm handing over to Jeff. Thank you.
Yeah, thanks, Ravindra. You know, I think I like some of the things that he called about, which is when you're thinking about migrations, there's still a lot of planning you have to do. DataSync is going to help you with a lot of your, the basic data movement challenges and things like that, but there's still a lot of planning that needs to happen in order to pull off a successful migration. So it pays to put in the effort up front and really avoid some of the challenges that can frequently trip up migrations. So just wrapping up real quick, some of the key takeaways. So DataSync gives you these data movement capabilities for those 4 use cases I mentioned: migration, archive, replication for data protection, and then data movement workflows. You can use DataSync to move your data between on-premises storage, edge locations, other clouds, and within AWS. We provide those different network endpoints and features for your secure, fast, and reliable data movement. And then you can maximize your available bandwidth using multiple tasks, being able to scale out like that. And as Raghavendra said, you can also use that bandwidth throttling to control potentially how much network bandwidth you're using as well. So if you want to learn more, definitely check out our DataSync website. We've got lots of blogs, tutorials, references, videos, things like that. You can check out that QR code, and that'll take you directly to our website. Definitely would also encourage you to continue with your AWS storage learning. We've got lots of different capabilities out there for you to learn more about the storage capabilities that DataSync provides, and ultimately lead to some of those earning some of those AWS storage badges. Again, the QR code leads to that URL there. And with that, I just want to say thank you for your time. Hopefully this was useful. We're going to take some questions off stage if you got them, but thank you very much.